Okay, so now we are into class B amplifiers. So class B amplifiers, you see in class A amplifier, can anybody say where the Q point of the transistor is present? In class A amplifier, where is the Q point located? In class A amplifiers? Yes, Rakshana, you are there?
Yes, sir.
In class A amplifiers, can you say where is the Q point located? Where is the Q point located in class A amplifiers? Anybody else can attempt
At
this
the
question?
center, sir.
Yes, at the center of Q point, because I want my transistor to work for the entire duration. But in class B, it is the transistor is going to work only for 50% of my time, or it is going to work only for 180 degree of my input cycle. So for positive half cycle it is going to work. For negative half cycle it is going to be not conducting. So I am going to make my Q point exactly at the cutoff. You see here, the Q point is exactly on the x-axis. See, usually Q point is here, but now you see it has come down to the Q point is present here. Why I am moving to cutoff? Because during the negative half cycle, no current should flow. So no current means it is going to be in cutoff region. So that's why the Q point is shifted from the middle of the load line to the x-axis. You have to understand how the Q point is moving for each of the amplifiers. Okay, so that is why they have given the Q point of the transistor is biased almost at cutoff. Either it is exactly on the x-axis or somewhere slightly above the x-axis also you can keep the Q point. See, all these load lines are imaginary lines. You cannot physically see them. It is only for your understanding. Please understand that, okay? So the transistor is going to operate in class B mode if I'm going to make R2 equal to 0. R2 means the voltage divided bias circuit you have, right? In voltage divided bias, if I make that R2 equal to 0, then VB will be 0. So if VB is going to be 0, the transistor is not going to turn on at all. Okay, that is how you ensure that a positive half cycle full amplification takes place. For negative half cycle, the transistor is not even turning on because VB is made 0. So when you compare class A, class B amplifier is going to have a lot of advantage because it is going to produce greater power output and higher efficiency. This higher efficiency is possible only because of the transistor is on only for 50% of the time. Otherwise, the efficiency will be very poor and negligible power loss because no signal is flowing at the negative half cycle. So the power loss is going to be very, very